Welcome back. So this is chapter 6, security, privacy and data integrity. This is A-level computer science 9618 P1, and today we're going to start with this chapter, right? So let's begin. All right. So security, privacy and data integrity. Security. When we talk about security, which means we need to the requirement for data to be recoverable if lost or corrupted. That's security. For example, if your computer has been shut down by accident or if there has been some kind of a malware, and so you should try to back up the data before anything could happen like that, right? So that's security. Or for example, if you are installing anything like anti malware or antivirus, all the security, so that's also data security. It's securing your data from being corrupted or being lost, right? So security means the requirement for data to be recoverable if lost or corrupted. Privacy, we all need to have privacy for our data, right? Like for example, if you have a Facebook profile and you want some privacy, you try to you just hide your information, from others, individual or strangers. So the privacy for the data is really important. Okay, some such data which is secret, privacy for individual, privacy data for each and every individual user who is using the app. And we need to try our best to stay away from those apps which try to sell out your data, which is violating your privacy rights. So the requirement for data to be available only to authorized user. Integrity means a data which is consistent. It has not been changed in some manner. Like if you are transmitting something, if you're when in during a transmission of a data, it has not been corrupted or it has not been changed in some manner. So we need to make sure that there is integrity as well. So the requirement for data to be accurate and up to date. So security, privacy and integrity, these three are really important. Security measures to protect computer systems. There are a lot of security measures. Like for example, if you have a user account, so access to a computer system is only possible with a user ID and the required password. Password, we only know what is, we make a combination of letters and integers to make a password, so that only you could access it and no one else. Digital signature is it's a signature. Like for example, if you're digital signature, we all know what is the meaning of signature, right? We put a sign and just try to verify that yeah, this is me signing this is my signature. But now it's saying digital, so there is some kind of a signature which can be done in digital form. So which try to tell the whenever you try to send something, we will just put a digital signature on it, telling the receiver that yes, this is confirmed that the that the file is from me, right? I'm the one who sent this and this is my signature. It confirms that. So yeah, it's a huge step for security. It always ensures that it's a confirmed source, right? It's a reliable source, it's authentic. And yeah, so digital signature means check integrity of the message to ensure that the electronic document is authentic and has not been altered in any way. Okay, that's also one point for digital signature. An individual can encrypt or an individual can encrypt a message with a private key. Okay, private key, public key. What are private key and public keys? Public key is something that can be used to encrypt the message and can also be used to decrypt the message, but it is public. Anyone can use the public key, right? Anyone can access this key because it is public. Private key is decrypting the message, ensuring only owner can read it. Encrypt the message to confirm all the okay. Private key, public key, these are keys. And public, which means it is public, anyone can access it. Private, which means only the either encrypt the message to confirm, encrypt the message to confirm, or either the sender will have this private key that he or she will use to encrypt the message to confirm the author of a message, or the receiver will have a private key. Only the receiver will have a private key. Okay, no one has the key or except the one who wants who has been given the private key by the sender. So there's a relationship between the sender and the receiver. The sender will have the public key to encrypt the message, and the private key will be sent to the receiver, and the receiver will try to decrypt the message. This is one case. The second case is the sender has the private key it will try to decrypt it and encrypt it, and then it will send this to the receiver and send the public key to decrypt it. Okay, so that's it's really not that important right now. So it will be discussed further in A level computer science P3. Okay, right, this is P1. So you just need to have an idea that what is public and private key. It's nothing, it's not really that important, but still, so don't worry. Okay, individual can encrypt a message with a private key. So it says a private key. Individual can encrypt a message with a private key and send this to many recipients who have the corresponding public key and can therefore decrypt the message. Okay, so we encrypt the message using a private key and decrypt it with a public key. This approach would be used if it was to verify who the sender was, who sent the message, right? So only the sender has the private key, and the public key only work with that one specific private key. Therefore, using this way, the message has a digital signature identifying the sender. Unfortunately, using digital signature does not consider the fact that someone might forge a public key and pretend to be someone else. Okay, this is you will discuss further in A level, in P3. Don't worry about it. You just need to understand that at some point, digital signature really important. It really helps. It really solves half of the problem, right? So what are the ways? First of all, the message is put through a hashing algorithm. The message, okay, hash total is encrypted. After getting a hash total, it will be encrypted with a private key. This is a digital signature. You put a message in a hashing algorithm, and after putting it, you will get the hash total, okay, and then you will encrypt that hash total with a private key. So that is a digital signature. Then what will you do? In step 3, you will send message plus encrypted hash, which is a digital signature. Send. You might get an idea. You might have got the idea. Digital signature message. It's like, for example, you're purchasing a laptop or anything on Amazon, and you want to make sure, and you just and the sender who is selling you that product will also attach a digital certificate ensuring that you have purchased the right store, right, the official one. Like, for example, if you are purchasing a laptop Surface Pro for Microsoft on Amazon, so the Microsoft people, they will try to give you the certificate or something like that. I'm just giving the example, right? They will give you the signature, ensuring that it is confirmed that this is from Microsoft. Okay, this is authentic. You can purchase from here all the stuff. That's the example. So message plus encrypted hash digital signature. Send receiver is in possession of sender's public key. Okay, so yeah, the receive hash total is decrypted with the public key. The receiver hashes. Okay, after it got the message, first of all, it will use his he or she will use his public key to decrypt the hash total, which was the digital signature was encrypted, right? So we will try to decrypt it with the public key, and also we will try to hash this we'll also try to hash the received message, just to confirm that the hash total before and after is equal. Before, the hash total was encrypted, and after, before we have calculated the hash total, and after sending it, the receiver will also try to put into a hashing algorithm the message, and it will be compared. The two hash total will be compared, right? If SH match HS, then the message is authentic and is not been altered. Okay, one thing for sure that it is authentic because we have just decrypted the digital signature, and the second thing is that the message has tried to hash again, using the hashing algorithm. The receiver got the hash total, and so before the hashing total and after hashing total, if they are equal, then it has not been altered. So this is the digital signature. Okay. Firewall. What is firewall? Prevent unauthorized access to and from a private network. Implemented in hardware, software, or combination of both. All messages entering or leaving the private network pass through the firewall. Firewall is more like a gate which try to check each and everything, right? All the private network pass through the firewall, and firewall try to prevent unauthorized access to and from a private network. Okay, Antivirus, what is antivirus? Carries out a regular system scan to detect any viruses and remove them or deactivate them. Anti-spyware, it detects and removes spyware programs installed illegally on a user's computer systems. Encryption, encrypting the data, making it impossibly to understand without encryption key to decode it. Encryption key like public key and private key, right? Okay, so that was the security measure to protect computer system, and now we're moving to threats to computer and data security. There are so many threats. Virus, spyware, it's example of malware. It comes in malware, replicate by inserting into another piece of software. Software that gathers information by monitoring. Like for example, if you are entering your PIN code of a bank account and the spyware software is installed, and anyone who have installed the spyware will have the access of all the information that you are entering it, from your keyboard. Hacker, illegal access to a computer system without the user's permission or knowledge. Phishing, redirect website to a fake website. Obviously, if you try to click on a link, or you get emails and unwanted emails, and just try to click on the link, you will go to a website which is fake website, and it will, like for example, having a fake bank website, and you're just entering your PIN code and you've been fraud. Okay. Farming, through email attempt to obtain somebody's confidential data, install malware, or getting confidential data. Okay, that's another example. Security method for data. Okay, if data have been lost or have been corrupted, what are the best way to recover that data? What are the security measures for it? Data backup. Create regular scheduled backup in case of loss, damage to the live data. A copy should be available. For example, if you are using WhatsApp, so you try to back up all the data through in WhatsApp app. Access right to data. Different access right for individual groups of users. Obviously, if you're using a computer and you have different access rights for example, if you're in a university and you have the computer and you just put your ID and password which has been given to by your university, you will access the computer, right? So this access right to data. Different access rights for individual groups of users. Certain username can read and edit certain part of the data. Encryption. If there's unauthorized access to the data, it makes sure that it's encrypted so that the data is unreadable. So encryption also helps a lot. Encryption it takes place whenever you try to it takes place between a web browser and a website. They try to share the information. It's always going in encrypted form. About HTTP and HTTPS. It's all about that. Using a SSL certificate. So for example, having the bank so many banks out there in the world, and every bank have a banking website, and every banking website has a SSL certificate. It's a certificate. It ensures that the data which has been transmitted between a user and a website is encrypted form, so that any hacker would not try to steal that data, right? So you need to have the encryption. Okay, now we have come back to data integrity. So data integrity, we all know what is that. Checking whether the data is consistent and it has not been altered in some manner. So there are some ways to check. Data validation, data verification. Okay, and data verification during data transfer. Okay, so data validation. Data validation is a check that data entered is of the correct type. It does not guarantee that data is secure, right? Range check, check whether data entered is between a lower and upper level. Format check whether data has been entered in the agreed format. Length check whether data has the required number of character or numbers. Presence check to make sure a field is not left empty when it should contain data. Existence check if data in a file or a file name actually exists. Limit check only one of the limit, upper or lower. So that's data validation. Validate the data for the correct time. Data verification, confirm what has been entered. For example, double entry. We use double entry when we try to create a new password in a when you're making a Google account and you are trying to create a new password. You will use this. You will have the data double entry. You will have to add, you will have to enter the data twice in order to confirm that the password you have been making is correct. Data is intertwined and then compared. For example, when making a new password, there will usually be a request for that password to be re-entered. Visual check what has been entered. We try to see it for yourself visually, right? Check digit. Okay, check digit. You all have been seeing this when you are going in a market. You will have this check digit, right? It also one of the ways for data verification. So an additional data added to a number. It's an additional digit added to a number, often used in barcodes, ISBN and VINs, can be used to ensure the barcode, for example, has been correctly inputted. IBN 13 code with check digit. Okay. So what we have here, 1 2 3 4 5 6 7 8 9 10 11 12 13 digits, and each one of them will try to multiply by 3, and each the odd position, in even position we will try to multiply by 1, and in odd position we will try to multiply by 3 and then add them up. So like 1 3 1 3 1 3 and so forth. So these are the odd positions, multiply by 3 and add them up, and these are the even position, multiply by 1 and add them up, and you will get this, and you will get the value. So this is the check digit. So data verification to data transfer. Checksum. Data is sent in blocks, and an additional value which is known as the checksum, which has been calculated, is also sent at the end of the block of data. At the receiving end, the checksum is recalculated. From before sending, it was calculated, and after being received after being received, it again been recalculated from the block of data received. After comparing it, if having the same value, then the data was transmitted without any errors, and if it is different, then there might be some, the data might have been altered during transmission. So this is how you get to know whether data has been transmitted correctly or has been altered using checksum. Parity check. What is parity check? Each byte has a parity bit. Okay. Before data is transferred, an agreement is being made between sender and receiver, regarding which of the two types of parity use: odd parity or even parity. If it is odd parity, then having odd number of bits, and if it is even parity, then having even number of bits. Parity bit is set to 0 or 1 to make parity for byte correct. Parity bit is used to set 0 or 1. So using parity bit, we can make even bits, even parity or odd parity, to make parity for byte correct. After transmission, parity of each byte is rechecked. If it is different, then an error is flagged. For example, so this is the data and this is the parity bit. So using the parity bit, we can convert to even parity or odd parity. Okay. Parity block. Even though an error has been flagged, it is impossible to know exactly which bit is in one way to use is using parity blocks. Even if we found that an error has been flagged, it is impossible to know exactly which bit is an error. We are talking about the parity check, right? So instead we will use parity check is used to just to know whether an error has been flagged or not. If it has been flagged, then it would be impossible to know where the error is in which bit. So one way to use is using parity block. We go in further, right? Data is arranged in a virtual table with parity bits added to each row and column. So parity bit added to each row and column. Identify any row with incorrect parity. Repeat the process for each column in sequence. So this is how it looks. Okay. So this is a parity bit. This is bit 2, bit 3, bit 4, 5, 6, 7, 8, and so for example we have been agreed for, like, the method not only identify that an error has occurred, but also indicate where the error is. The drawback is that multiple corrupted bit would also flaw this system. Okay, so how many bits are there? 1 2 3 4 5 6. Okay, for example, we have been agreed about even parity that we will going to use. So from each row and column it must be even parity, right? 1 2 3 4, okay, 1 2 3 4 5 6, okay, 1 2 1 2 3 4 1 2 1 2, okay, 1 2 3 4 5 6 1 2 3. Okay, so now this seemed to be an odd parity. We have been agreed on even parity, but it's showing odd, so there's an error in this row. The others are fine. 3 4, okay, now we're going to see in this way. 1 2 3 4 5 6, correct, it's an even. 1 2 3 4 even. 1 2 3 4 even. 1 2 3 4 5 6 even. 1 2 3 4 5. Okay, so there's an odd parity here, there's an odd parity here, and when having an intersection, we have found the error. So the error is in here, okay, and the others are fine. So this is how you try to not only identify that there's an error, but also where it has occurred. Okay, but the only drawback is that multiple corrupted bit, it is only one here, but having multiple corrupted bit would also flaw this system. So this is parity block, and I think this is the end of this chapter. So congratulations, and we will move on to chapter 5 and 4 in next week. Thank you so much. Good.